Voyager's story is one of humanity's boldest leaps into the unknown. What was never thought possible has now become reality. A mission that has traveled far beyond its scheduled lifespan, redefining the limits of space exploration. Even more astonishing is that this lone spacecraft, now billions of miles from home, continues to beam data back to Earth using technology older than a cassette player. And yet, it has just made a discovery so profound that it's left scientists and the world stunned, questioning what this revelation means for our place in the universe. It all began with a moment of brilliance. Gary Flandreau, a visionary at NASA's Jet Propulsion Laboratory, uncovered something extraordinary, a rare cosmic alignment of Jupiter, Saturn, Uranus, and Neptune. It was the late 1970s, and calculations revealed that these four giant planets would soon line up in a way that created a unique gravitational pathway. Like beads on a celestial necklace connected to Earth, they would allow a spacecraft to slingshot from one planet to the next, gaining speed with each encounter. This gravity assist would slash a journey to Neptune from 30 years to just 12. But there was a catch. The alignment happened only once every 176 years. NASA had a narrow window, and they seized it. In the summer of 1977, just 15 days apart, two nearly identical probes were launched, Voyager 1 and Voyager 2. Their mission was to exploit this rare planetary formation, a task that would ultimately lead them to shatter every spaceflight record in existence. Originally planned to last only 4 years, these twin explorers not only achieved their primary mission but also ventured into the deep unknown, far exceeding expectations. From the start, they delivered wonders. Their early flybys of Jupiter and Saturn gave humanity breathtaking close-up images of moons that were far from the frozen, lifeless rocks we once imagined. Instead, we saw volcanic eruptions on Io, icy landscapes on Europa, and atmospheric storms swirling with alien beauty. Voyager 2 became the first spacecraft in history to visit Uranus in 1986 and Neptune in 1989, revealing secrets no telescope on Earth could have captured. The data they returned redefined our understanding of the solar system's outer worlds, showing that these distant planets and their moons were far more active and complex than scientists had dared to dream. Now, more than 14 billion kilometers from Earth, these probes, no larger than a Volkswagen Beetle, continue their journey. They have crossed the boundaries of the solar system and entered interstellar space, carrying the voices of humanity on golden records, messages meant for whoever or whatever might one day find them. Their voyage began with a daring gravity-assisted maneuver around Venus, a technique never attempted before, which gave them the speed to embark on their grand tour of the outer planets. On the way to Jupiter, they braved the hazardous asteroid belt, a challenge that had only been overcome by the Pioneer 10 and 11 missions before them. The challenges were immense, the odds uncertain, and yet these spacecraft endured, weathering cosmic radiation, micrometeoroids, and the deep freeze of space. And now, decades after leaving Earth, Voyager 1 has detected something so strange, so unexpected, that it has scientists searching for answers. Whatever this mysterious signal means, it's a reminder that even after 45 years, space is still full of surprises, and the Voyagers are still out there, exploring it for us. Voyager's journey has been nothing short of miraculous, especially when you consider the limits of its hardware. With just 69 kilobytes of memory, a fraction of what even the simplest modern smartphone can hold, its onboard computers had to operate with remarkable precision and self-reliance. Data collected by its instruments was first stored on track tape recorders, then transmitted back to Earth using a transmitter that consumed only 23 watts of power, about the same as a household light bulb. Communication depended on massive 12-foot wide satellite dishes, sending and receiving radio signals at the speed of light. Yet, with every passing day, the gap between Voyager and Earth grew by 3 or 4 more light seconds, making the task increasingly difficult. By the time Voyager 2's signals took over 18 hours to reach Earth, the challenge had become monumental. On top of the vast distances, there was the rising interference from human-made radio noise, televisions, cell phones, and countless other sources, threatening to drown out the faint whispers from the spacecraft. Still, against all odds, these probes have continued to send their priceless messages home, each transmission adding to a legacy of discovery. Beyond our planets lies a mysterious frontier, the Oort cloud, a vast shell of icy, comet-like objects held loosely by the sun's gravity, stretching almost to the nearest stars. Though the Voyagers are still many decades from reaching that realm, they have already crossed into interstellar space by passing through the heliopause, the invisible boundary where the sun's influence ends and the galaxy's domain begins. Scientists once believed this crossing would occur at around 50 astronomical units from Earth. When the Voyagers neared that distance, NASA made the decision to keep funding the mission, hoping to witness the moment. But when Voyager approached and crossed this threshold, there was no sudden environmental shift, no dramatic spike in cosmic rays as once expected. Instead, the change was subtle, leaving researchers puzzled. High-energy particles from distant supernovae should have flooded the region beyond the heliosphere, but most remained deflected by the sun's magnetic shield. Equally baffling was the behavior of the magnetic field. The interstellar magnetic field should have pointed in a different direction than the sun's, yet the readings remained stubbornly familiar. And then, on August 25, 2012, Voyager 1 confirmed it had made the leap. It detected the telltale rise in plasma density predicted for interstellar space, undeniable proof it had left the solar system's protective bubble. Yet there was still no shift in magnetic field orientation. This discovery challenged long-held theories about the nature of our solar boundary. The evidence suggests that the edge of our sun's influence may be far stranger, more complex, and more intertwined with the galaxy than anyone imagined. After 45 years, Voyager still carries humanity's curiosity farther than ever before, reminding us that even at the farthest edges of our reach, the universe refuses to give up all its secrets.